Alright guys, welcome on back. So, I know we had a lot of confusion this last week. I had a student introduce a new way of doing factoring that I hadn't thought about, but as it turns out, I actually did know this way of factoring. It was just introduced in kind of an interesting way. So, I wasn't planning on doing this until the new quarter, but because we already went over that confusing lesson, and just so you guys know, it doesn't work. The way that we did it in class, for those of you that are my students, it just doesn't work that way all the time. So I'm going to show you guys, or maybe I was doing it wrong, I don't know, but I'm going to go ahead and show you guys a different way of doing this. It's called factoring by grouping. It looks really similar, and I think this is what we were going for. Okay, but let's go ahead and explain what factoring by grouping is. Speaking of which, I have a factoring by grouping. I believe it's called the binomial factors of, hold on, I will link it in the description, but it is called the binomial factors of polynomials. And what it is all I'm looking for is to pair up my values so that I have some greatest common factors to pull out. In this example, I've already got them separated out here, but I've got my these two and the, oh, sorry, you'll want that plus sign and those two. Okay, you always want your signs, you'll just want to split them up like that. And all we're doing is grouping them where I know that I can pull out something. So a situation where factoring by grouping would not work is if I have zero common factors anywhere. So if this didn't have an x and this had like a z, and this one didn't have a y, and this one was like a, I don't know, an R or something like that, then I would not be able to factor by grouping. Factoring by grouping only works if there is a common factor. There has to be some number or letter that I can pull out. Okay? So over here, x squared and 2x. We've already done this greatest common factor thing. Let's look at the numbers first. 1 and 2, technically the greatest common factor is 1. You don't need to write that, okay? You really don't need to write ones. Because if this is all I can pull out, that means my factoring by grouping is probably not going to work out. But anyway, and then let's go to my letters. X squared and x. Remember, you want to take out the variable with the lowest degree. So there's x to the first and x to the second. We want to pull out the lowest, so that's x to the first. Alright, and let's go ahead and simplify what's inside here. What's left over is x squared divided by x just leaves us with 1x, and 2x divided by x just leaves us with that 2. Alright, that was supposed to be a green parentheses. Now over here you've got a positive xy and a positive 2y. So let's go, and this is going to give us a good example because now we'll start with the numbers. 1 and 2, what's our common factor? Again, your common factor is always going to be 1, but you know, I'm going to go ahead and pull it out just for example's sake. Alright, let's go to my next letter, and I'm going in alphabetical order. Here's an x to the first, and an x to the 0 technically are no x's at all. Since there are no x's, I cannot pull out an x. The other way to think about this is that I have an x to the first, an x to the 0. I can pull out an x to the 0, but anything to the 0 power is 1. Okay, so I could technically pull out x to the 0, which is just 1. That's a 0. I'm sorry, that didn't 0. Okay, so x to the 0 is 1, so it doesn't make any difference for what we're doing. Next, we're going to go ahead and pull out, we're going to go to our y's. We have y to the first and y to the first. If they're both the same power, I can go ahead and pull out whatever it is, because 1 would be the lowest one here, so y to the first. In reality, this second part, 1 times x to the 0 is really just 1, times y is just y. So in this second one, it's technically just y outside of my parentheses. Okay, and then we're going to divide here. xy divided by y just leaves us with 1x, and 2y divided by y just leaves us with our 2. And what you'll notice here is that in my parentheses, I end up with the same value. This is that grouping factor because we're going to group these up. Because they're the same, we're going to group these up. Alright, so you're going to group up your 2x plus 2's, and then you're going to take whatever's left over and you're going to group them up. Technically it's this, but I'm going to use this, the simplified version, just because that looks really ugly and is a mess. Okay, so you have a 1x, or just an x. I'm going to write that as just x. Okay, remember 1 times x is just x. And then over here, again, technically it's plus all this stuff, plus 1 x to the 0, y to the first. But again, I'm going to take the simplified version, plus y. Oops, sorry, I said plus. Okay. And that's how you factor by grouping. I know that was really quick and I didn't really write out the steps, but that's because I have an entire like 11-minute video on how to do this from way back when. I'm going to go ahead and link that in the description. So if you need more help with factoring by grouping, feel free to hit the link in the description. Go check out that other video. It is longer. It's like 11 minutes. I think it uses the same example, but I do give a step-by-step process for that. Okay? So that's factoring by grouping. We will practice this. Now, let's talk about what we were doing, factoring trinomials with a non-1 leading coefficient. That's what we were doing last week, where I had a student try and introduce something new, and it turned out to be the right answer, but it really doesn't work every time. Again, I may have screwed up the method, but I'm going to go ahead and show you a slightly different method that I think is what we were going for. Okay? Don't forget to go ahead and skip back and pause if you needed it. I'll show it at the end of the video as well. But what we're going to do, and don't let all this confuse you, I'm just putting it on the screen so you can start writing it if you want. Feel free to pause. I'm not sure if I'll get all this page on one screen, but we'll get you a chance to copy all of these. Feel free to pause anytime in the video. So what we're going to do is we're going to break down this value of 3p squared minus 2p minus 5. Okay? So 3p squared. What I'm going to do is I'm going to walk you through how to do all of this on a sheet of paper, and then I'll bring these steps back up. Okay, these steps are the words for what we're going to do, but I'm just going to show you how it works first. All right, 3p squared minus 2p minus 5. Your first step is to go ahead and multiply a by c to get a new number. Okay, multiply a by c. So 3 times negative 5, 3 times negative 5 is negative 15. So you're going to multiply your a term and your c term together. Don't forget your signs. So if you have a negative 5 or a negative 3, don't forget that negative, okay? So multiply these together, we get negative 15. Cool? So what I would do is I'd multiply these together, I get negative 15. And then what you're going to do is find factors of the new number that add up to b. Alright, so remember our b is this negative 2. Again, don't forget your sign. That's important. Alright? And we're just going to factor out 15. Negative 15, mind you. Negative 1 and 15, 1 and negative 15, 3 and negative 5, negative 3 and positive 5. Okay? And if we were to add all these together, oh, you guys can't see that. Negative 1 plus 15 is 14. This is negative 14. That's negative 2. And that's positive 2. Okay? And you'll notice again, remember we needed to add up to b, our negative 2. So the only pair that adds up to negative 2 is that 3 and negative 5. Okay? 3 minus 5 equals negative 2. Alright, I'm actually going to keep it on this page because I realize this page is organized really well, and I planned that out a lot better than I thought I did. Okay, so 3 minus 5 is that negative 2, and that's what we're looking for. So this is our new pair. Okay, this isn't too different from anything we've done thus far, but here's where it's going to change a little bit. What you're going to do is you're going to rewrite your original equation while replacing b with your factor pair above. Okay, so this factor pair that you found, you're going to rewrite the whole original equation, but you're just going to replace your b here, this middle term, the whole thing, and we're going to replace it with these two. Don't forget your letter that's attached. Okay, so in this case I'm using p. This could be an x, a y, it doesn't really matter. But instead of writing negative 2p, I'm going to write positive 3p minus 5p. Okay, so rewrite the original equation. 3p squared, you know that hasn't changed. Negative 5 didn't change. In the middle here, this negative 2p, I'm changing it now to positive 3p minus 5p. It also doesn't matter what order I write these in. It would work out either way. Okay, I could have written this as minus 5p then plus 3p. It really doesn't matter. You're going to just write them however you figured it out. Alright? So that's step 3. You're just replacing that middle part. And the reason we can do this is because negative 5p plus 3p equals negative 2p. So we're not changing the equation, we're just changing the way it looks. Alright? So feel free to copy these steps down. Again, that's steps 1. Step 1, go ahead and pause. Step 2, go up to step 3 down here. Okay, feel free to pause that video, and we're going to move on to step 4. Here's the last step. Alright, guys? Our last step is to do our factoring by grouping that we just went over. And what I did was I rewrote my equation, 3p squared, again, plus 3p. So remember, I'm using this new equation that I've got. And I'm just putting parentheses around the first two terms and parentheses around the second two terms. So parentheses around the first two terms, parentheses around the second two terms. Make them look like two binomials essentially. Okay? And then we're going to do our greatest common factor. Over here, 3p squared and 3p. Remember what you're doing is you're pulling out first the number. What number goes in both 3 and 3? What's our greatest common factor? It would be 3 because they're the same number. And what is the lowest degree between p squared and, again, this is p to the first, technically. So I get to pull out, between p to the second, p to the first, I get to pull out p to the first. Okay? And then what we'll do is we'll go ahead and divide our terms. 3p squared, 3p. So 3 times what equals 3? Just a 1, which I didn't write here. P times what equals p squared? It's a p. Okay? And 3p divided by 3p, or 3p times 1 would equal this. Basically this times 1 would equal 3p. 3p divided by 3p is 1. Alright, because it's the same number over itself. And over here, we're going to do the same thing. Again, we'll start with the numbers. -5 and -5, what's their greatest common factor? They're the same number, so -5. And p, and technically p to the 0, but no letter here. Because there's no letter, I can't pull out a p. Alright, so now let's go ahead and just figure it out. -5p, how do I get from -5 to -5p? All I'm missing is that p, so there it is. Alright, so -5 times p would equal -5p. And then -5 times what equals -5? -5 times 1 equals -5. There's that 1 there. And you'll notice here that both of our, so after we pulled out our factors, both of our binomials look exactly the same. This is going to happen pretty much every time as long as my numbers are pretty and whatnot. So for all purposes of your examples, this works. Alright, again, this only doesn't work if I don't have any common factors. Like if this was 3p squared plus, I don't know, 8z to the 8th. P and z don't go into each other, 3 and 8 don't go into each other, so my life wouldn't have changed at all. And then over here would have to be the same thing. So this would have to be like -7p minus 5, because then p doesn't have a common value, and -7, -5 don't have a common factor. So that would be the situation. When you cannot pull out any greatest common factor, then you can't factor by grouping. Alright, so anyway, what you get down here is you're going to group these. Remember, it's called factoring by grouping, so because they're the same, we're going to group it, and then we're going to group up whatever is left. In this case, a 3p and a -5. So I just grouped those up and I wrote them here. And then you are done. Just to prove that this does work out, let me go ahead and FOIL it out. So 3p times p is 3p squared. Outer 3p times 1 is 3p. -5 times p is -5p. And then -5 times 1 is -5. We'll go ahead and combine our like terms here. Minus 2p minus 5. And that does give you your original equation there. Okay? 3p squared. 3p squared minus 2p minus 5. It is the same exact thing. Okay? So again, there's step 1 and 2. There you go. Step 1 and 2. Step 3. Okay. And then step 4. Alright? So that's all it is. Keep in mind, remember when we're factoring, this would be our final answer. So that's the answer I'm looking for when I say factor. Okay, so this is factoring by grouping and factoring trinomials using grouping. Again, I didn't plan to teach this just yet, but because of the confusion last week, I thought I would go ahead and clarify. Alright guys, again, I'm going to go ahead and link the other grouping video in the description just in case this was too fast. The other one stretches it out over 11 minutes. This one I did pretty quick. Alright guys, so best of luck. Let me know if you have any trouble. Oh yeah, and I'll see you guys next time.